Hey, my beauties, how are you doing? Hope you're doing all very well indeed. Part 2. So, radiometric dating. I wish this was great flood evidence, but it doesn't seem to be, except for a flood 500 million years ago. In possibly a similar mechanism to the so-called biblical Great Flood, which may or may not have happened. I was hoping this in Central Australia was evidence for that Great Flood, but it doesn't seem that way. I'm always pro-scientific on this channel, but my definition of science is very rigorous. You have to really prove it. So I was pushing grok, I was pushing AI last night for hours and hours, couldn't sleep, trying to work this out, find the flaws in radiometric dating. There are a few flaws. We'll discuss them. But it is generally a very, very good system. Now, how did this form? How did this happen? It's an uplift. We see it's an uplift. It wasn't formed, this wasn't pushed together in situ. It was uplifted. And we see this you can see the stratigraphy there. So it was pushed up like that. Something happened and then eroded. Something happened. Radiometric dating. It's a very good system. The system is good because it cross-checks itself. So if there is a damage to a sample, it won't cross-check with other radiometric dating methods. The good thing about it, and this was always confusing me, but I've worked it out, for myself at least, the mineral is dated, not the rock. And I was always thinking, well, look, you can't really apply this to sedimentary rock. In some ways you can, but that is the case. You actually cannot apply it that well to sedimentary rock because you're dating tiny crystals inside a sedimentary rock, or you're then you don't know the origin of the sediments around it. But that depends on other things as well. We know it works because new minerals date at 0, old minerals date very old. How does it work? So what happens is the mineral is a closed system. The isotopes build up inside a crystal lattice, and it seems they can't escape. And so long as this remains the case, we see isotope accumulating inside the mineral until that mineral is disturbed and broken up in the laboratory. We can see how much isotope was there, and this shows us how long the sample was locked up there. And it seems to work really well. It's a really good method. So lead's one of the oldest ones to date the age of the Earth from the meteors, from the meteorite fragments. And then that dates the solar system to about 4.5 billion, oldest Earth rock, 4.4 billion. So Earth is somewhere in between those two dates. And that really does seem to work. I'm not a creationist by any means, but being a historian, I can't ignore what they'd say about the Great Flood, and I can't ignore that geologists don't talk about it. So the problem is not in radiometric dating. We know the rate of decay is constant. That's a possible flaw because it's been cross-checked with other radiometric methods. It's cross-checked with the fossils in the layer deposition. We can even date the sedimentary layers roughly by crystals inside the sediments. So the methods do cross-check against each other. I've suggested some flaws. What about internal heat? If these rocks have been cooked inside the Earth, that would suggest a uniformity of dating. That would suggest a mechanism for the cross-checking. But the problem with that is you can take some of these zircons up to 800 degrees. They're still okay, just from memory. And if the sample truly is broken, it's not going to be dated anyway. It's not going to cross-check with the other dating methods. So so we can see if there's been a disruption or not. Space disruption, I've suggested cosmic rays. There's not that much evidence for it. Because we have these 2 billion year old nuclear explosions in Gabon, Africa. And we see from that the rate of decay has been relatively constant for a huge amount of time. So it's really hard to refute radiometric dating. It's a really good system. So how would I suggest there's issues with it? Okay. And I'm not suggesting there's an issue with what's happening in Central Australia. There might be, but the issue is human error. What about human error? And that is the problem. That is the flaw I see in the system. Firstly, the geologist's personality. If the geologist is determined to prove something, they will. if I'm determined to prove something on this channel, I probably will. So I'm not always right, and I can often get it wrong. In this case, I was hoping all these uplifts, the Petermann orogeny in Central Australia, would have been from the Great Flood of maybe 30,000 years ago. But I cannot prove that. I have to follow what's been done, and this is correct. But what about overconfidence? What if the geologist is only selecting certain samples and rejecting other samples? And what if there is an unwillingness to discuss any Great Flood in the origin of the Petermann orogeny? And that, I suggest, is a main flaw, because we don't know how that happened. The geologists themselves say that is extremely unusual. And it is. You see, there's only a few places in Australia that look like this. Uluru being one of them, and this nearby. Maybe the Bungles in Western Australia might be part of it, I'm not sure. But it is quite unusual, this. And there are some further flaws, I'd suggest. It's on a hill, so you see the eroded elements, but Uluru is similar to this. It doesn't have the huge, it's not made up of the huge boulders that this is, but Uluru, I don't see fragments of Uluru littered that much around Uluru, so I wonder how old it really is. There are some flaws. And this is sedimentary rock. Can you date sedimentary rock? You often can't. In this case, it seems they can, and they have got it right. It's 500 million years old. We'll look at that. Okay. So let's look at all. When I went to these places, this place is incredibly dry. And I'm suggesting in this video, because geologists don't know how this uplift occurred, because it's in the middle of a plate. Is it tectonics? Is it with India crashing into Australia or something like that? I would suggest a new novel mechanism, and that mechanism is mantle groundwaters have forced their way up from the mantle, and there was a great flood of the earth, and that is how it was created. And a geologist will not talk about that. It's all about the volcanism. Only volcanism can come from the earth in the geologist's mind. And with my method of talking about a great flood that created this 500 million years ago, suddenly some things can start to make sense. That's what it looks like. Rivers coming down off of it. It does seem to be a massive hill. It's a mountain, basically. Look at the rocks. Look at this. I want you to look at this very closely, people. It's all made up of this conglomerate, and these are huge, huge stones. They go all the way up, all the damn way up. And this is huge, this thing. It's massive. It towers over you. It's all like this. We know that only the most ferocious storms can bring huge boulders to the top of a beach where they will be deposited. Otherwise, they're not going to move at all. And these are all piled on top of each other. A great catastrophe has occurred 500 million years ago. Massive, absolutely massive. And the geologists themselves say it involved a huge amount of water. There was a massive amount of water to push all these together 500 million years ago. So I'm suggesting it was an aqueous disaster that created this. So if it happened 500 million years ago, why not more recently? And I think you'll find that the geologists will tend to shy away from saying, oh, this was created by water. They'll say it, but when they discuss it, it'll be in terms of plate tectonics did this. It's not water that did this. And part of the reason is there is actually stratigraphy here. They'll look at a 600 million layer, a 500 million layer, a 400 million layer. So they'll say, okay, the whole thing is a plate tectonic uplift. But they'll also say the sediments were formed 500 million years ago. So we can look at that sediment specifically in terms of a flood, I believe. So don't think about the whole thing. Think about what's happening 500 million years ago. Whew. And another problem I had was how weak these stones are. This is supposedly 500 million years old. And when I was there, firstly, take water. Even if you take water, it won't save you. You can drink a litre every half an hour, you'll still be dehydrated. It is that dry. It is really bad there. Don't go. But it feels like the ground literally looks like what Mariner is walking over. That stuff is kind of weak. It's sandstone, which is essentially silicas, which acts like a glue. And also maybe some possible... you can't really see the organics, so it's not black, but possibly iron ore, because it's red. Iron ore also tends to act like a glue for sandstone. So this is all sandstone, not limestone. So it's hard to talk about it in terms of an inland sea. But it's, and this is a problem I had. All this stuff, it's really crumbly, even around Uluru. It's like, it's not that strong. And you think, is this really 500 million years old? So just that alone makes me question some of these radiometric dates, despite the fact that I can't poke a hole in them. I really can't poke a hole in them. They seem to be a really good dating system. It's a mystery to me. How do we know it's 550 million years old? The sedimentary rock is made up of pebbles and boulders, primarily granite and basalt. So those sorts of things you can date because the minerals inside those are locked up. Cemented together by sand and mud. That's harder to date, because now you're dating different things. The conglomerate is a remnant of alluvial fans that eroded from uplifted mountains, and much of the mass extending deep underground. The rock is a type of conglomerate, meaning it's a mixture of different rounded rock fragments cemented together. Clasts. The individual pieces are cobbles and boulders, mainly. So geologists have their own language. This is what they call a clast. We call a rock. But it's a rock that's possibly been a bit shaped into something, mainly of granite and basalt. Cement. They are bound together by a matrix of sandstone, mud, and sandy sediment. So we're looking at 500 million year old mud. And to be honest, some of it's still kind of muddy and clayey, and it's sitting there for 500 million years ago, not eroded. It sets my alarm bells going that something's off with radiometric dating, even though I cannot poke a hole in it. Has it been somehow flooded again more recently? The conglomerate is a result of a geological event 500 million years ago that uplifted mountain ranges. Yep. The mountains were eroded and the resulting debris was deposited in large alluvial fans. Over time, overlying sediments compressed and cemented the material into conglomerate that forms Catachuca today. Covers more than 20 square kilometres. That's Catachuca alone, but the whole thing, the Petermann orogeny, is it's hundreds of kilometres. It includes Uluru and much more. Mount Olga is 546 metres above the plain. It's huge. And Catachuca is really where the catastrophe occurred, more so than Uluru, because the conglomerate is far bigger boulders in Catachuca than in Uluru. Uluru, it's just made up mainly of sand. It was a much smaller catastrophe that occurred there. And how do we know? How do we know? I always push it, and I was pushing it, and I was saying to Grok, why is my intuition saying this is wrong when I know it's right? And I know it's right. And it said, well, because you're being a scientist, it's okay to push. And it said most people don't push this hard. They just accept it. They're like, trust the science, bro. They accept it. But you didn't. That's good. And it says often you can, that's how discoveries are made, because you keep pushing and something's off. You know something's off, but you don't know what. And I don't know what. But let's keep going. The conglomerate was later buried by sediment and lithified or turned into rock. The age is dated to 550 million years ago because it is contemporaneous with the formation of the Petermann Ranges, which were uplifted during the assembly of the Gondwana supercontinent. Conglomerate composition. The rock itself is composed of a wide variety of rounded rocks, including granite and basalt cemented together. It's a conglomerate. Large rounded pebbles indicate they were transported by powerful, fast-flowing river system. So what I'm suggesting in this video, forget the plate tectonics, this was done by water. This was done by a type of Great Flood 500 million years ago. And the Great Flood repeats and repeats and repeats. In this case, we're looking at something very old. In other words, Mantle water, I believe, breaking out in this area. An explosion, boom, and there's your uplift. And I don't think the geologists want to say that just yet. But they might watch this video and a paper might appear, because it's happened to Roger Spur of Mud Fossil. He's talking about this layer of, and then in 2016, a paper appears saying there's this worldwide muddy layer of soft tissue organisms they've just discovered. And he said, I was just trying to talk to this guy, and now he publishes a paper on it. Anyway, interesting stuff. Sediment burial, but I don't know the mechanics of that discussion, so I don't know who discovered it was. So I'm not making any assertions there. Sediment burial. So let's go further. So I really pushed Grok on this one. How do we know? How do we know? How do we know? So firstly, the stratigraphic, although we don't use it for sedimentary, we don't use for sedimentary dating, we don't use the dating that much. We can look at the stratigraphy, and we can look at the fossils. We can see that the conglomerates of Catechuca overlie the Neoproterozoic sediments in the Amadeus Basin, and are in turn overlain by Cambrian marine deposits. So we'll see the first life there, right there, in those deposits above it. And we can just recognise the deposits by looking at them. Geologists can see the same deposit in different areas, and they know what sort of rocks and ages are associated with those deposits. So that is a fair argument. I can't look I don't feel the need to prove something when it's against the prevailing, not the prevailing opinion. I don't care about that. The prevailing evidence from a really good method. The method of superposition, young layers on top and cross-cutting relationships, faults and folds from the orogeny, cut older rocks, place these deposits at the late stages of the Peterman orogeny. Erosion from the rising Peterman ranges created alluvial fans of conglomerate and arkose, coarse sandstone, which are then buried under 2.5 kilometres of sediment and later tilted. You saw that tilt in Catechuca by a subsequent event, the Alice Springs orogeny. So then there was another one. It tilted one way up, and then it went up. It did it again. Another Mantle floodwater explosion. It's in the middle of a plate. Geologists can't explain it. If you're a geologist, chime in. Tell me what you think about my theory. Absolute dating by radiometric methods. So, and this is you can't argue with it. The only flaws I can find are human error. Do the humans want this to date this way? And this is the case. But then the problem is another geologist will come around 40 years later and come up with another date. So eventually, if this is wrong, it will be exposed. That is happening with skulls in Africa and America. They're saying stuff we dated to 7,000 years ago might be 30,000 years old. They were trying to just get it published, fit the data, massage it a bit. We know this works. What I really like is that we look at the metamorphic and igneous rocks, which are easier to date. And we can date that to the uranium lead in the minerals inside those rocks. Yes. So that and then we see that then that fits the sediment because and then I asked, okay, so then I asked, the conglomerate in the sandstone is the iron oxide and silicate. Now that's a problem with dating. So how do you date those? That would help you date the sediment itself. So yes, actually, believe it or not, yes, there are dating methods for that as well. The key is distinguishing, was the sediment laid at different times, is what they're saying. So yes, apparently, and that is a problem. So that is a problem it mentions. What if it was disrupted and then redone? And that is a huge flaw. But we don't necessarily see that because we see the stratigraphy. But even the stratigraphy doesn't show what's happened in, say, over 50 years, 100 years. That's whatever happens there won't necessarily be shown. Maybe. Right. And it turns out inside the sediment there are tiny crystals which can trap radioactive decay in situ inside sediments. And these are phosphates, and it seems these match it to the dates that have been come up with other methods. So it's really hard to argue that this Uluru, etc., isn't 500 million years old. There is an underlying rock under Uluru, which is also it's different to this sedimentary layer. That needs to be pointed out as well, and that was part of the uplift. So, I mean, it is hard to argue with this. It really is. So, we're looking at a system where we don't know how this formed, but they say plate tectonics. I'm suggesting in this video, look, massive flood pushing boulders, a great flood 500 million years ago, and again it seems 320 million years ago. And I say that with reservations. I believe some of these rocks are really weak. They're almost muddy. Did it happen more recently as well? Anyway, guys, hope you've enjoyed the video. That video suggested further evidence for the Mantle floodwater theory, except 500 million years ago, maybe also 360 million years ago in the past. Especially if you're a geologist, tell me what you think. Cheerio, people.